See, molecular hydrides. So we have seen that the definition of hydride again and again. Many times you should memorize it. And many times, if you hear and if you listen, so what will happen automatically? It will be uh, always permanent memory. It will go to your permanent memory, and you will never forget these terminologies. Hydrides. So hydrides are the binary compounds of hydrogen. There are strictly three types of hydrides. There are strictly three types of hydrides: molecular hydrides, saline hydrides, metallic hydrides. So first is molecular hydrides. So examples we have seen. But further molecular hydrides are classified as into three categories: electron rich, electrons precise, electron rich, and electron deficient. Three. What is the summary of these three? Or we can say abstract. Electron precise means in which all the valence electrons of the central atom are engaged in bond. Very important point. When central atom forming bonds, most important, valence electron are involving in the bond formation. Such molecular hydrides are called as electron precise. Precise is sufficient. Octet is complete. Next point is, what is the meaning of electron rich hydride? You see, the hydride in which there are more electron pairs on the central atom than are needed for bond formation. That is, there are lone pairs on the central atom. If there is a lone pair on the central atom, such hydrides are called as electron rich. For example, you see water. Yes, any one of you can tell this is the water and it contains two lone pairs. Whenever the central atom having the lone pair, such hydrides are called as electron rich hydrides. Right? Yes. Electron precise means, for example, you see CH4. CH4. You see here, so you see all the valence electrons of the central atom, there are four electrons in carbon valence electrons. So they involved in bond formation. Electron deficient, what is the meaning of the deficient? What is the meaning of electron deficient hydrides? Electron deficient hydrides means those hydrides in which there are too few, very less number of electrons to be able to write a Lewis structure for the molecule. So it is very important. See, so how we can judge this? How we can take the example? How we can understand this? For this, we will see the next point on this. So it will be easy for all to understand. See, you see, electron precise is this. Electron precise. Okay, you see. So electron precise molecular hydrogen compounds, or we can say the molecular hydrides, include the hydrocarbon. So hydrocarbon is the best example. See here, methane, ethane, higher alkanes, okay, propane, butane, all are the hydrides. They are molecular hydrides. Selene is also there. Selene is also, uh, we can see the electron precise hydride. The reason is, if you see the selene, so it form. If you see the selene form, so you can draw a structure like this. See, You know, and if you write the electron configuration of selene, so selene can be, yes, 2 comma 8 comma 4. Okay, so 4, there are 4 valence electron in the selene, and all 4 valence electron of the selene are involved in the bond formation. Fine, you see, so you can observe this. Fine, right? Yes. So selene is a, again, so have a clear cut idea what is the meaning of electron precise. It's every atom, every electron of the, or all electrons of the valence shell must form the bonds. That's all. Then this is germane, selene and germane, selene, germane. Germanium is the central atom, and this germanium, silicon, they are the members of carbon, and we know the all the atoms of the same group must possess the same number of electrons in their last shell. So carbon family is like this: carbon, silicon, germanium, tin, lead. Okay, yes. So this is the so germanium is also the member of this. So definitely the it will have the 4 electrons in last shell. If you draw the structure of germanium, so you can see here. You see, yes, germanium. So like this, you can see GH4 having the central atom is germanium. In germanium also there are 4 valence electrons, and hence it it involves all valence electron in the bond formation. There is not a single electron residing unbonded or without involving in the bond formation. All these examples are electron precise molecular hydrides. One more terminology can be used here. If you see, you select 2 centers. This is what? Hydrogen. You see, this is hydrogen, this germanium. So 2 centers are there, hydrogen and germanium. And there is a one bond. Means how many electrons? Yes. One bond means 2 electrons. So we can say 2 center, 2 electron bond. Right. So remember the point. So this is the example. Yes, remember the point. Normal bond. Normal bond is what? 2 center, 2 electron. This is called as 2 center, 2 electron bond. And there is no lone pair on the center atom. So 2 center, 2 electron bonds are there. Two is a very normal bond. 2 center, 2 electron bond. Okay. So the bond is depend on is are formed by 2 electrons. Remember the point. The bond is formed by 2 electrons, and it is between 2 centers, right? You can take any example, no problem. You take any example. For example, you see CH4. You see CH4. Yes. If you select the center, suppose you have selected this center. This is the center, suppose. Okay. Suppose this is the center we have selected. This is one more center, two centers, and there is a bond. But one bond is how many electrons? Two electrons. So this is a two center, two electrons. Remember the point. The two electrons is rotating or is in between the two centers only. This one bond or two electrons are in between these two centers, hydrogen and this carbon. Okay, this is called as the molecular hydrides and electron precise hydrides. Now see, electron rich hydrides. What is the meaning of electron rich hydrides? So especially compounds of group 15 and 17, we can say binary compound. Binary compounds of group 15 and 17 are called as electron rich. See, examples. See, first of all, we should know the group 15 element. Nitrogen family is called as group 15, right? And halogen family is called as group 17. So the compounds, hydrogen compounds of the group 15 and 17, the ammonia is one of them. Water is okay. We can take the water also. And because it is a 16 group, and this hydrogen halides, HX. Okay. So all these are the electron rich. So after carbon, the next family is nitrogen family, then oxygen family, then halogen family. All are the examples of electron rich hydrides because they form the lone pair. There is a presence. For example, you see ammonia. If you take ammonia, yes, how many electrons in ammonia? Seven electrons. And EC is what? 2 comma electronic configuration 2 comma 5. So when you read ammonia, yes. So you see out of five electrons, only three electrons involved in bonding and the remaining one electrons is in the form of a lone pair. And therefore this ammonia is electron rich hydrides. Remember the point. Therefore, ammonia is the electron-rich hydrides. You see? Yes. Okay. Fine. Similarly, you can go for water. Just now we have seen we can draw hydrogen halide also. Then electron deficient hydrides are those hydrides which are found by only group boron group. Yes. So one of them is, see, first element is boron. Before carbon there is a boron. Boron. So carbon, nitrogen, oxygen, fluorine. So these hydrides of these families is electron rich, electron precise, and electron deficient like that. Why? Because if you see the boron atomic number is 5. So 2 comma 3. So 2 comma 3, fine. So you see there are only 3 electrons in the last shell of boron. So boron can form only 3 bonds. So according to Lewis concept, whenever the atom do not complete its octet, it is called as a Lewis acid. It always in search of electrons, right? So when this boron utilizing its 3 electrons for the formation of bonds, you see here. So there is always one vacant orbital remain on boron, and that therefore it is called as the electron deficient hydrides of boron. And hence this boron BH3 exists in the form of dimer. Remember the point. Due to this electron deficiency, this BH3 molecule exists as a dimer. And we can write like this. Yes. Okay. And you see, then they further explain that B2S is called as diborane. Now you will see the figure of that diborane. And you can see here what is the about diborane. This in diborane you see here there are two types of bond. This is a boron and hydrogen. BH bond, this is a BH bond, BH bond, BH bond, BH bond. Fine. These are called terminal bond, and these are called bridge bond, bridge. Okay. No, but what is the point? What is the point? This BH bond is a two electron, two center, two electron bond. Remember that. But what about this? What about this bond? What about this bond? This is two electron. This bond is two electron, three center. You can see here. This is what this bond, because this bond is start from this boron and goes to the boron. It's like this bond is like this. Okay, this bond is like this. Is called a banana bond, and there's a hydrogen. So three centers are there. Three centers are there. So hope you understand this. Boron Hb. Three centers, only two electrons. Similarly, this also three centers, two electrons. Two types of bond. This is a strong bond, and this is the strong bond, and this terminal bond is strong, and this is a weak bond. Okay. So this is what about the electron deficient hydrides and especially diborane. See here also